So good morning, good afternoon, regardless of where you're at coming from the world, that should cover you. This is Damian Bowersock, Technical Sales Manager with Green Bytes. Here today to talk about something a little bit different. At Green Bytes, we're pushing the envelope every day with new technology as it relates to storage and trying to bring technology up to the same level of sophistication that we've seen in the compute world over the last 10 years or so. The problem is that we're stuck in this old school thinking. We're just mired in this nonsense that really came from 15 years ago. So I want to take you through kind of the history, real briefly, of the storage environment and how it was driven, and kind of take you to where we believe we are today. So if you think back, 15, 20 years ago, and I know there's a lot of storage guys out there that probably don't remember this, but back in the early 90s and the late 80s, mainframes ruled the world. And the great thing about a mainframe is it was a time-sharing based system. So people would come in, log into their green screens, do their daily workload on a centralized system in a server room somewhere. The problem with that from a storage perspective is that it was completely centralized from an I/O standpoint. So the time-sharing system created lots of random I/O all over the place. And the only real way to combat that was to create disk subsystems that were cache-centric. You've heard the statement, cache cures all. It truly was the means for solving these issues on the mainframe. Cache-centric systems exist today much in the same state that they existed 20 years ago. You've got the EMC Symmetrics, which is now the DMX line, the IBM Shark platforms, the early Hitachi systems. These were all big, expensive, cache-centric systems. So, from the mainframe days, though, we moved into really what ended up becoming distributed computing. And we pushed out the compute power to the individual servers in the 90s. We spread out the applications on these little 1U, 2U, 4U boxes, mostly because they were cheap. And Windows came out and a network-based operating system and lots of reasons to move into distributed computing. But what that created were these little islands of compute power associated with a small island of I/O associated with a particular application. And so that was fine. We could do direct attached storage on the server. Then we started to run into the problem where you had an application that grew outside the bounds of the disk system that was attached to it. So you had the question, do I buy more disk or do I build a bigger server? So the answer then was, well, let's just build a SAN. Right? We'll take these little pockets of I/O and then we'll create a SAN-based system that centralizes all of that in one rack. We didn't really virtualize the storage or pool the resources in any way. We just created these little pockets of I/O. And we went through these crazy calculations to determine how to decide how many disks to use for a given application. It looked a little something like this. We had some I/O requirement that we had to meet from an application perspective. And we knew that a given drive could give us a certain number of I/Os per second. So if we divided the requirement by the I/Os per drive, that would give us our spindle count, the number of spindles that we needed to meet that I/O need. Then we would run it through the RAID calculations based on whatever RAID type we wanted, and that would tell us how many actual drives to provision for a particular I/O requirement. And again, this goes back to the idea that we're not really centralizing I/O. We're not really striping multiple applications across multiple disks here. We're creating tiny little pockets of I/O inside of a bigger disk subsystem. It didn't really scale well. That drove us to where we're at today with 30 and 40% utilizations on SANs. And so, that got us through the 90s, that got us through the early 2000s. But something started to change in 2003, 2004. Something started to change in the way we did compute, and that came in the last 10 years. And that thanks to VMware and thanks to Citrix buying XenServer, virtualization has ruled the planet as far as the traditional distributed computing model. So what we've gone to is back to the days of the mainframe type world, where we have multiple applications riding on top of a single larger, more powerful server and centralized all of our resources again. What that's done, though, is it's created the same random I/O problem that traditional SANs can't solve because that's not what they were designed for. What it leads us back to having to do is creating cache-centric systems today. And that's really where GreenBytes comes in. So GreenBytes, as many of you know, we've taken industry-leading inline deduplication technology, built a cache-centric system, and really have provided an architecture completely designed for virtualization. So there's lots of cache, 24 gigs of RAM-based L1 cache, up to a terabyte of L2 SSD-based cache. Our inline deduplication algorithm ultimately reduces the I/O workload that a system has to do. And the other thing that's important for this kind of environment is we're based on a transactional file system. And what that does is it takes random I/O and puts them into large wide stripes that can be written across low-cost SATA drives very effectively. So we're basically optimizing random I/O and turning it into sequential for cheap and cheerful drives. So if you're ready to get out of the old school model and quit thinking about, oh, how many spindles do I need for this particular application, and start thinking in a virtual way like you do with VMware, then check us out. Also, if you like the presentation today, this is done using a little website. You can see the watermark down in the bottom left corner, Prezi.com. I'm not here to sell you Prezi, but it's a great little tool.